So it is my pleasure to introduce Bill Stevens. He's a distinguished licensed professional geologist across multiple states, including Pennsylvania, and the current president of Friends of Mineralogy, Pennsylvania chapter. As president of Stevens Environmental Consulting, a comprehensive environmental consulting firm established in 1995, Bill brings over 2 decades of experience in serving the Mid-Atlantic region. His extensive geologic expertise, GIS skills, surveying acumen, and passion for mineralogy converge as he leads initiatives to inspire and enhance the success of fellow collectors. Bill's impressive track record includes mapping renowned mineral occurrences such as waverlite at the National Limestone Quarry in Snyder County, showcasing his commitment to advancing geologic knowledge and exploration. So let us please give a warm welcome to Bill Stevens.
Yep. All right. Thank you, Al. Welcome, everybody, and thank you for your warm welcome. Anybody that knows me, my condolences for the rest of you. Steve knows me. Yeah, I'm so sorry, brother. The rest of you prepare for a wild ride. We're going to pop through several different sites this evening. And I'll just say that none of these are active Stevens environmental projects. They are more pet projects of mine, where I'm more or less combining and applying skills obtained in the surveying and land development engineering and environmental consulting arena. And I have a few tools or toys. I like to play with them and try to improve everyone's opportunities for being successful in their mineral collecting efforts. So let's see which way it goes. And I will say I'm also the current president of the Eastern Federation of Mineralogical and Lapidary Societies. We have 92 clubs currently with nearly 9,300 members from West Palm Beach to northern Maine. That takes a lot of my time. And you'll see some video in here that was done by Andrew Dirt, if anyone who's familiar with his Dirt Man reports. Yeah, he took some video in here you're going to see. So modern mapping tools, basically the tools of the trade are twofold: software and essential equipment. So I use ArcGIS, QGIS to avoid paying for the full-blown ArcGIS. That allows us to have scalable displays, to plot things to scale, analyze public and private data sets from imagery to LiDAR topography or DEMs to a host of thematic data that are useful for us as geologists, consultants. And then there's Google Earth. Everybody knows how to use Google Earth. Quick location, mission planning, other functions it's great for. We'll typically, for a flight, we'll go to Google Earth and digitize a polygon around the area of interest, and then export that as a KML file and load it right into the controller. And that is much easier than using your thumbs to move the little dots around on the little controller. If you're a drone mapping person, it's a great tool. CAD and survey mapping software. We have Carlson and PC Survey. Carlson is a pretty great software, but PC Survey I've been addicted to since I started my business like over 28 years ago. And it's a lot cheaper. But the bottom line is you need some CAD software if you're going to be processing data from your GPS or robotic total station or any kind of survey data. So phone apps, I don't know if anybody knows or is familiar with SoLocator, but it's a free app. And you can take a photograph and it'll give you the direction, distance, your latitude and longitude, more or less to car GPS accuracy. And there are strike and dip calculators and onboard mapping apps that you can use right on your cell phone. Rockworks, anybody familiar with Rockworks? Very broad, very powerful, very expensive software. But if you want to do a rose diagram, you can use GeoRose or something like that to get a plot. In the drone mapping arena, I use Pix4D. We used Pix4D initially with our first drone, got away from that because most of what we were doing were just orthomosaic. So we used drone deploy for a while. Then drone deploy started changing their software, and we were getting very poor results even when we gave them actual survey ground control points. So we've gone back to Pix4D, and it does a fantastic job, and it will process the smart oblique flights from our new drone. And then online research. I don't need to tell geologists how important research is. There's no reason to be duplicating effort. And a lot of the books that are over here and other books that I've dumpster dived for over the years, or even taken off the top of the shelves out here, contain maps that are at a large scale that are useful, that have never been reproduced. You can scan them, georeference them, use them in ArcGIS or like a rubber sheet, collect data off of them, put them into the data collector, go out in the field and map. So for mapping, you're going to need a GPS Base-Rover or a network rover for survey quality ground control points and other type of data collection. You're going to see how we use that tonight. I have a robotic total station. We do conventional surveying with that. I can do it one man if I want. In the old days, it took a great team of surveyors, rear chainman, head chainman, rod man, instrument man, yada, yada. 3, 4, 5 guys, even as recent as 1980. But with the modern technology, the robotic total station can take survey measurements both to a prism or even to reflectorless directly to a surface. I could set up here and I could shoot all the corners of this room and draw a map without ever walking over there. You just need 2 points with known coordinates. So a mapping drone for photogrammetry and or LiDAR. Our latest and greatest is the Mavic 3 Enterprise, if anybody's familiar with that. Does a smart oblique, which is fantastic. It eliminates the problem with nadir only when you have vertical surfaces and they get fuzzy and warped. And we geologists, we like to see vertical. All the quarries, the walls are vertical, so need to be able to see it. And then there's laser scanning for ground-based LiDAR-like mapping. That's expensive, and it's also the training and the software is very expensive. Most people that are using that are using Bentley, and the lowest version of that I think is over $10,000. So just to give you an idea of what our modern mapping tools are, this is a site out in St. Louis, 82-acre mall. I just flew 3 weeks ago. This is on the left-hand side here, this is my little TopCon Hyper SR Network GPS unit. You can see the cradle about just above the top of the bipod. I actually have a tablet, and I'm sitting in the car because it was cold and windy. I didn't want to be cold, so I took it off. As long as I'm within 30 feet or so, we can get a set of GPS observations. On the right-hand side there is the new Mavic 3 Enterprise by DJI. Good Chinese drone. The Chinese make good things, right? Yeah, right. Anyway, they're dominant in the industry, and as a result, they're the least expensive drones. This one has an onboard RTK, so as long as I have my phone and it's getting corrections and I'm using it as a hotspot, the controller will get the corrections, and instead of having phone quality or driving quality GPS positions for each camera shot that's taken, you can get centimeter, 2, 3, 4 centimeter level because it's getting real-time corrections from the satellites. Improving the position of the cameras makes the solution a lot tighter, and you don't need as many targets on the ground. So this is a Trimble S6 robotic total station. That's my brother-in-law. That's the boiler house at the Martin Army Hospital in Georgia. We're mapping that. Guess what? The government doesn't allow us to fly drones, so we have to do all that work the hard way. And but it's not that hard. It just takes more time. It's easy to fly, but it's also easy. Just takes more time to get the field work done. So one of the things that's important when you're setting control is you want it to be as permanent as you need it to be. for you guys who are doing sinkhole work or any kind of quarry work, you keep going back year after year after year, you want to set permanent control. The nail's permanent enough for, you know, a couple of weeks, a month, but it's subject to freeze. They might hit it with a mower, get a hold of the whiskers that are on there and suck it right up in the mud. And then that's the end of my point, but I'm never going back, so I don't care. So this is a case where you do care. This is the new Paris Quarry. And we were just back there for the Friends of Mineralogy Symposium on November 11th of this year. And ahead of that, the weekend before, I went back out to find the target control points that I had set over a year before. And because I use Network GPS and because I can get good solutions with that, with, you know, within a centimeter, I literally put that point into the GPS unit and navigated directly to it using the stakeout mode. And there it was. The one on the right got sucked up by the mower. So I put a spike in this for this year in approximately the same position, and you can see the paint. So here's one that was set in the floor of the quarry on top of the, well, not on the top, but on the upper beds of the Jersey Shore. You can almost make out a couple of the wings of the paint mark. You can see the little yellow disc. So I just painted it up again so I could fly it one more time. Nothing's changed. So we're going to jump now to an actual fun project. These folks, Shane and Sherry Moore, they do have real jobs, but they're really heavy into crystal collecting. They're up at Herkimer all the time. They have a piece of property leased. Originally, they started at a claim in Diamond Acres, which is a farm about 100. They have about 80 or so leases in there. And if you want to get a claim, you have to wait for somebody to die or give it up. And there's a waiting list. So they got in there. Within a few years, they mined the heck out of it and got down to the Druzy layer. So they started looking for some other sites. And Area 52, which is east of Canajoharie, and probably 5 miles as the crow flies, almost due south from Diamond Acres, was their second location. So I call it a top-down mine. And the reason for that is you scrape off the overburden, which is largely glacial till, and you're right on top of the pocket layer within a few feet. Other places that you'll see, like Mohawk Valley Mineral Mining, are they're on a steep slope and it's digging into the bank. It's not nearly as fun. So on the left-hand side here, you can see the drone map. You can see the, let's see if I can get my cursor over here. But down in the left-hand corner here, this is the 1-foot pixel resolution imagery, the kind of stuff we're accustomed to using. And this is the drone map. This was flown with a Mavic 2 drone and 9 targets, 1-foot targets. And here we have contours, 1-foot contours on the other side here. So that was generated in drone deploy, which I didn't really have any control over. So it gives you topography on top of the trees. Drone deploy doesn't allow you to do any editing, but it's fast and it's expedient. And, you know, we just trimmed the edges in arc. I left a little bit of it in there for effect. Let's see if we can, whoops. There we go. Oops, I went too fast, too far. Ooh, stop. So we're blown up here, and you can see there's piles close to the working areas. This is a hole. I got started out here on the edge. Shane said, "Hey, we're going to give you a pocket because you were so nice to come out here and fly our site." I'm like, "Oh, that's great." The only problem was he dug it out. And he gave me the crystals, but I'm like, dude, I want to dig, you know. So they kept after it, and they started really getting into some nice stuff. And but you can see the mat here, and on the right-hand side, this is Shane getting ready to pull out a pretty good size crystal. I don't think we have any sound, but that's okay. All right, there you go. So that's a honker. It's about 7 pounds. And it's skeletal, fenstered, and mud included, and fluid included. and. Unusual for Herkimer. But this has become the thing there lately, are these big skeletal crystals.
I'm not gonna complain.
No, you're not going to complain. $7,000 later, he's not going to complain. There's a really nice one that's about 1.5 pounds, 2 pounds. The surfaces are warped, which is interesting for quartz crystals. Most of us are familiar with the conventional Arkansas rhombohedral termination. They're always flat faces. These skeletal things are not only skeletal, but faces are warped. We wonder and speculate that the petroleum that's present in the bugs' pockets may have played some role in this, though most of it was thermally matured to a solid. And we know that because we see the inclusions of what's called anthraxolite in the crystals. So things just keep going. This is me trying to measure the depth from a topographic point that I could pick off of that map, so I know exactly how deep it is. You know, they found some more as they're going on. They did attempt to bore down, thinking that they would hit the druzy layer that they saw at Diamond Acres, in their pit at Diamond Acres, and they just never made it. So we're not sure that it's the same buggy zone that they're pulling the skeletals out of. The pocket that you see on the west wall there was empty. And you can see that's just a lot of material moved around. Things are changing every weekend when they're really busy. Here's one of the crystals I pulled out. I'm sure this thing exploded. I'm sure there's a big fluid inclusion in the middle of it here on the left, and you can see the healed faces are warped. Interesting growth. I bet if you put it under the scope, you'd see a lot of strange twinning. And this was a sort of a both sides of a pocket that came out of, a big bridging piece there I didn't feel like removing. So we're going to jump to Mohawk Valley Mineral Mining. This is, you can tell just by looking at the background here that this is not a top-down mine. You're digging into the ledge. And the further they dig back, the more overburden has to come off. It's more like ACE. So my little mission that I decided to do, which cost me a skeletal pocket, was I wanted to make sure that there wasn't anything in these lower beds from the lower road, at least most of the way up the hill to the pocket layer, which is the big buggy zone, is all up here on this ridge. And people have been digging at it. So what we found was, this is a valley that was carved out by glaciers. There's wedges of glacial till, and we know that that's going to be barren as far as crystals go for people who like to dig crystals. Only the black topsoil that you see on the right-hand soil is going to contain anything. There may be stump holes that are deeper, but this till, obviously, any crystals would be crushed to dust. And you know it's till because obviously you've got some glacial erratics in there. So this was the second skeletal crystal to come out. And we did edit out the F-bomb, I think. He was pretty excited.
But it's still kind of like crunchy.
Yep.
So the pocket's full of
Keeps going, doesn't it?
Yeah, it goes.
rotten saddle dolomite and anthraxolite.
Oh, yeah.
And those of you who are in the petroleum industry know up in New York State the importance of saddle dolomite lined buggy reservoirs. It's a big thing. It's complex. So he's going to pull this out eventually.
It's gonna take my time to find that piece, because it's huge.
I don't know if we want to wait that
I'm gonna
long.
abandon science and just go right for the pocket.
Yeah. I abandoned science. All right. So this was a more challenging project to try to map. I was able to obtain 2 foot, and these are 10-foot contours I'm displaying, but I was able to get 2-foot LiDAR contours that were fairly recent. 2017, there was a FEMA project because of the Mohawk River. If those of you may remember that enormous flood, they had to 15 inches of rain or something, and it flooded everything out along the Mohawk. So that generated some dollars from the feds. And you'll see the little roadways in here. This was the beginning of me. I had a pair of GPS control points out in the open ground and basically started traversing with a robot as best I could, trying to get down there. It was very, very uncomfortable. But what I found was after I surveyed all this bench, and these green dots are specific pockets of real interest, that it seemed to fall right on the 620 contour, which is what I've got highlighted there. The beds are nearly level. If they're dipping so gently, it's virtually imperceptible. And then there's another pocket zone about 40 feet above that. And I've got that highlighted in that pale teal. And this is a zone that's actively dug, and this just happened to be some pockets I saw along the side of the road. I did get strike and dip data, but I never bothered to process it because it's just too much field work to do. So Willie Fallon was the guy who found some really large clusters, and we videotaped that. That went up on YouTube. There's some stuff with the crystal. There's some things that Andrew put up. This Joe found the very first in place skeletal crystal. Donnie's was 9 inches away. Since then, we've identified a zone in here that seems to be the skeletal zone, whatever that means, we don't know. There's a roadside buggy zone. The owner's wife and her friends dig over here and smoke, hide from everybody, the customers. And then I got one over here that was 3.5 pounds. So without the imagery, that gives you an idea of what the relationships are. And just quick in review, a very, very similar skeletal pocket zone at Area 52 is at 820 feet. This is at 620 feet. And they seem to be on a block that has some, there are wedge faults out here, so there's differential movement one side or the other. And I'm beginning to think, and connecting the dots all the way up to Diamond Acres, if we're looking at the same buggy zone, that even though the dip is nearly level over a long distance, there is an elevation shift. Could be a fault in between, we don't know. So came back in April, flew it with the drone. You can see the difference. This is the trimmed edge, flown with the Mavic 2. I was able to digitize a little bit more of the roads. He had set up here in the upper left. This purple zone was a machine dig area where the customers could come in and pay $1,000, $1,500 a day to have him run the machine to open the pockets up for him. And you'd be surprised how many people book those things. I dig for free, so I don't know that that's a good thing, but at any rate, very, very nice outcrop now. I lost my. So you can see the difference in the quality of the imagery and the information that you can pick off of it. This is a JPEG of a PDF, and in ARC, it looks really fantastic. And it was just a $5,000 drone that flew it. So this is a blow up. The skeletal pocket zone is now opened up into an area at least as big as this machine dig area is indicated as of, I guess, July of this year, when we were there for a club related trip. So in May, Memorial Weekend, a gentleman by the name of Lee Levique opened up 2 pockets and now has the unchallenged 2 largest skeletals ever from Herkimer. A 14.1 that he, or 14.7 that he calls Medusa, and a 28.2 pound skeletal cluster that he's named Hercules after himself. So anyway, you're going to get to see that come out. Now we're all used to these little guys, you know.
Baby.
Look at that thing. That's half of it.
Mohawk Valley.
That's half of it, folks.
That's a smaller half of the cluster, and they went right back together. So it is.
Gotta get his twin brother.
Now, after everybody gets beaten on these rocks, they are very hard. The silicified dolostone, little false dolostone is extremely hard.
My God, get out of here.
That's the
You
big.
begin to see the actual fractures and you can exploit them.
Hey, get out of here.
Look at this guy.
Now, he's got a good sense of humor. He got like a plastic Roman helmet and
It's
put it
like
on there,
this.
photographed it. It sort of looked like a transformer crystal. Yeah. So that goes together with the other piece.
Whole crowd here witnessing history. Biggest yet by.
Yes,
God.
it went back
I'm
together.
like, it doesn't go right.
Fenstered, mud included, skeletal fluid included, just the whole bit. Very complex crystals and very large. No one's challenged that size yet.
I've been to Ace where, for diamond mine, where all the water clears are supposed to be the best. No. This
Look at the
is
size of
the
that
best.
pocket. I've opened up pockets that size and they were empty. Empty.
Best.
So here was the second one.
Mohawk Valley just saw his first pocket with massive, the biggest skeletals we've had come out of this mine. Here we go, pocket number 2, right next to it, about a foot away. Let's see what he's got. All right, let's start with the small one. All right, let's start.
Yeah,
with-
actually had to
Work our
come out
way
of
up
this
here.
one.
Yo, everybody, look at that! Holy crap!
That one was 8 or 10 pounds.
That is perfect terminated down there. Look at that, Lee. And that's the smaller one? Yeah. Oh.
Looks like it's clean all the way around, ain't it?
So the 3 crystals
Look at this,
here,
everybody.
he's had appraised at $160,000. I sent pictures of them clean to Peter McGall, the show chairman at Tucson, and said, I think we probably ought to have these
And then the big
these
one
in
comes.
the show. And he,
Here
so
we go, everybody.
they're gonna be in a cabinet, in a case at the Tucson
Oh.
General Show.
God.
Don't you wish you had that in Pennsylvania?
Look how beautiful those. That is amazing.
Yeah.
Good job, Lee.
So anyway, I'm gonna move on here. Those are just pictures of him. What a smile. What a great guy. He earned it too, trust me. He did, he probably out there 4 weeks, 3 machine digs. Okay, now we're skipping to another one. This is one of my favorite places. National Limestone Quarry at Mount Pleasant Mills. I've been digging there, I think, since 2015. I think the initial green was discovered some time around 2000, 2002. Various people have laid claim to doing it, but I think it was Eric saw it, and the owner saw some first and then had Brian Brookmeyer, maybe a couple other people come in and look at it. So that's one of my pieces there. That the shimmer is for real, you know, no acid, no nothing, just a pressure washer. Wavelite, phosphate. So here's an overview of the map from 2015 Google. This was from my first talk to the Delaware Mineralogical Society. You see the main pit. We get all the things that you would expect to get in the Tenala Way and the Kaiser. We get a little bit of celestite, a lot of nice calcite crystals, a lot of strontianite. But the wavelite is in the Old Port Formation, and it's in the Ridgely member of the Old Port Formation. And the contacts are pretty crazy. So they discovered it when they were putting a road through right along the property line. And it's steep going down that southern area. So here's a mine map on the left-hand side. The red triangles were my original primary GPS control points. Had one out on the road for a long back site. I think they paved over it or something. The right-hand side, you can just see the property lines, parcel lines are extracted. That's what the quarry looked like in 2007. Doesn't look much like that now. Here's a geological map, and the blue arrow over here on the right is basically pointing to the quarry. You can see it's the Kaiser is on top. The Tenala Way is underneath. It's in the quarry. The Tenala Way is exposed in the bottom. The Kaiser is the primary rock that's exploited for aggregate. And the old port formation, interestingly, he found a home for some of the Churty sandstone as fill. 80,000 tons of it, I think he sold one year. I think it went behind the dam. So here's the structural map on the left-hand side. This is one of PAG's publications. I want to say M72, but I don't know that that's right. It's typical flexural slip type folding. You see all of these joints, fractures. The axial plane was, the axis of the core, the anticline is exposed in the bottom. It is doubly plunging, so it's more like the picture, like the fold on the left here than it is on the right. Here's a blow up. Unfortunately, I lost track of the photo I had here of looking down into and on the old port formation. And it was really amazing that you could match up the joints and things, just right with the old structural map. So here's a picture down at the bottom of the quarry as it was way back in 2015. I literally shot some of these bed surfaces later on. Here's a nice picture. You can see the axis of the fold. It is kind of, I guess the plane is, axial plane is kind of dipping that away. It's very straight walled on the south and not so much on the north. And the contact with the old port is somewhere up here in the bushes. It's a little bit difficult to tell because the sort of the karst features on top of the limestone sort of blend in with the sand colored material of the old port formation. On the left-hand side here, you can see that neither fold axis that was exposed back then is exposed now. It's all covered up with a shot, but we could kind of trace out some of the beds. It's really crazy crunched up in the core. There's even some little back thrust things going on. You can see the drag on these beds. I tried to trace out with the yellow. Whoops. Thought that's just a picture, but this was April 2022 club trip and mapping mission. This was after the machine dig that I did in March. And you can see the fold is covered up down here now. It's even worse now, but we get a lot of clubbers coming in all the time to this place. It's sort of a mecca for mineral collectors in the state. And people have come from Ohio and even Florida just to come here and collect wavelite. There's no wavelite in the bottom of the quarry, and it takes some doing to get lay people who are coming to collect to understand they're not going to find any wavelite in the quarry because it's not in the right formation. So this was my attempt at drone mapping. Trust me, it was challenging. After the machine dig, this is what the west pit looked like. The east pit, we didn't really do anything there. You can see my control points. I had a very difficult time getting an observation on that one because of the trees. Phone signal's really bad. Some of these points that are down in the bottom, I shot from up here. These 2 points were GPS control points. That was a GPS control point. The rest of them were shot in with a robotic total station from the GPS control. You just can't get any GPS signal on the bottom of the quarry because you can't get satellites. They're shaded out by and you can't get a phone signal if you're using network. So, yeah, he's been selling this material, believe it or not, for fill. And some of it's quite colorful. And it has sort of the iridescent colors, violets and lilac colors, all kinds of pretty colors. People buy it for ornamental stone in their gardens. So once again, I think somewhere in here is the contact. I might have it a little bit low. It might be a little higher up here between the old port. Once again, we're looking at the upper and lower or west and easterly pits. This one was the most active. And here's our machine dig. Nice little drone flight. My employee, Aaron, getting an observation on one of our targets. There's a hub and attack in there. It lasted a couple of weeks before it got hit with a machine. So, the helipad, me sitting on my butt, running the controller, getting the shots. But we dug all of this end out to the extent that we could. And Ryan Klockner, anybody knows him, Geology 365 guy. He's the president of the Jersey FM. He and I did an awful lot of digging in here. This was much deeper before. OSHA would have had a fit. It's 12 feet deep. So and this is what it looks like now. The joints and things will really fool you. It's difficult to see where bedding really is. And there's a fault right here. I thought about bringing a chunk of breccia, which is really cool. So here we go with another picture. If you go to Mount Pleasant Mills to collect, there is a poster set up there with the mine map and these figures that we're going through right now to provide an explanation to all the collectors as they come and do their thing. So this is what we wound up figuring out. There's a barren zone in here, though this is loaded with fossils. I mean, it's nothing for people to pick up gastropods that just roll out of this loose chert and sandstone. This was mainly sandstone, but this left foot and a half is the breccia, and it has bugs with big wavelite in it. Ryan got one ball that's just shy of an inch, lemon colored, perfect, sits up, appraised at $1,500. So that's a lot for a phosphate, from Pennsylvania. But the productive zone, I try to explain to people where it is. They still go up here and dig. They're going to find something. It's very specific, and the clubs have had a really good time with it since it was reopened. Anyway, if you jump around to the other side where he's mining some of the material for general fill and ornamental stone, you can see it's standing up pretty much straight. And this is that phone app I was telling you about, SoLocator. It's free. You can pay like you could pay for strike and diff stuff and get more features. But I just use the free thing. You line yourself up with the bedding and take a picture and you got strike. And you got a decent position and a decent elevation, maybe. Sometimes I've gotten positions that were 1,100 feet out. And here's the thing, a point I wanted to make. You can tell where this fault is, and you can tell where bedding is because there's a death assemblage of brachiopods. There's a whole bed of they're all in their death or life or whatever position. And here's some of the breccia cavity vug fillings. That's some pretty decent wavelite. Mike Stefanik did, does anybody know Mike? He did his master's thesis on phosphates. Yeah. And some of those obliques earlier on in 2015 were taken by his buddy Chad. He actually flew his plane down so he could fly his drone. So, but this is pretty much, you could go there for a field trip and find some. So this is sort of some of my haul, and it hasn't been cleaned other than just pressure washed. A lot of this stuff has been sold. That was a nice piece. That was another nice piece. You see the stuff that's sparkly, and then you get the split ones that have wagon wheels. And we came up with some unique names with them, like Cinnamon Toast and Pina Colada, based on the colors. And trust me, they sold better. So, yeah, so here's a Pina Colada. This is a really nice piece. Mike Davis keeps trying to talk me into giving it to him. I'm like, yeah, right, sure. And this has a little bit of a coating on the outside. It's still largely wavelite, and you can see that their balls are layered, whatever the juice was at the time. What I found very interesting about this early on was that we see quartz crystals in veins all the way up into the coal measures. The quartz crystals here are broken, shattered, and the wavelite nucleates on them, over them, around them. So whatever this phosphate deposition event was, it was later than the quartz crystal deposition event. I call this a mint wavelite. Ron Sloto has tested a lot of this stuff. The mint colored has a little higher fluorine content. And I call that Dad's big piece of wave light as it goes all the way up to my arm. And Chris Rock with, Dad gets the big piece of chicken, right? So this is a solid piece of the breccia, and you get a really good idea, this is definitely a fault. I mean, there's no joke about that. And then how it's all cemented back together with wavellite. So, we have structural controls for the phosphate deposition. It's all in the Ridgely sandstone member of the old port. And the primary deformational style is flexural slip folding, though I'm pretty convinced that the phosphate deposition is a later brittle deformation event that may have been associated with something more recent than the last big tectonic event. There are other phosphates, which we, are in the full-blown talk on this. The planarite, turquoise, variscite, bauxite, and cacoxenite have all been found here by Ron testing with his equipment at Westchester University. Collecting's focused on 2 adits along Mine Road on the south side, but we think the phosphate-bearing beds are continuous between those 2 points and maybe beyond. So my thought for, our collectors is understand the geology, and you can enhance your collecting success. So now we're on to part 2 of the new Paris Quarry. I'm gonna try to blow through this. Everybody knows where New Paris is, right? Yeah. No? South of Johnstown. This site was acquired by a farmer from New Enterprise fairly recently, in the last few years. And Steve Lindbergh at Pitt Johnstown sort of manages it. He has a good relationship with the farmer there, and he brings clubs and groups to this location because there's a lot going on here. It's really cool. You're on the west side of the front, so it's not folded and bashed like everything there at Mount Pleasant Mills. So I think this is the second geological survey map he has. It shows you with the star where you're at. You're on the west side of the Chestnut anticline fold axis. Here's the geologic map. And this is part of the field conference from 2003. So if you've got the field conference, and you can download the field conference guidebook, you can get all that information. So what's interesting about this is you have the Jersey Shore in the floor. There's stromatoporoids, or I'm not a fossil guy, but stromatoporoids. Literally some of them this big in the floor. And somewhere up this bench, which you can't see anymore because it's all been covered up with a big shot that New Enterprise left us with. They were worried about people falling off of this cliff because kids were running in there partying, so they blew it. And now all of this is covered up. But the Silurian-Devonian boundary is exposed here, and you can kind of walk up to it. The Laval member goes all the way to the top here. There's a bench you can walk around. There's lots of fossils down here on this end. There's a couple of, maybe 3 bentonite beds, 2 documented in the literature. One a student thinks he's identified and recently. And then the old port's on top, but it's more limey than a lot more carbonate rock than sandstone. So yeah, the 2010 Google Maps, what it looked like back then, and you can see this great big shot pile here on the right-hand side. This was my first flight with the Mavic 2. Didn't yield the best results for contours, but they're better than nothing. We basically have nothing, so it's better than nothing. The primary control point from which I did robotic total station work was here, and I had a backsite up here on the hill. The rest of these points down in the quarry were sprayed in with the robot. And this is the Mavic 2 drone image. So when you're planning the flights for drone mapping, you have to have your targets on the ground, and they have to be inside your planned map. Our first plan tried to capture as much of the quarry as we could, but we couldn't get enough targets in. So we expanded it a little bit. Couldn't really do any more than this because the Mavic 2 drone was not very sophisticated and had a 18-minute life on a battery. Hot swapping batteries was no fun. This year, I recovered all but one point and set one new point where an old point was. So this is the newer flight. I tried to capture more of the parking area, and also we could explain to people where they needed to park and where they were going, and do it on a poster. And I provided posters to Pitt UPJ at the symposium, so they can point to those every time they take an organization out. But this is the actual flight digitized from Google Earth. The trees get very high here, and you still want to get details, so that's a balance. That's why this was tight like it was, because we really didn't know how high some of these trees were, and we didn't want to be so high that we didn't get good quality resolution on the ground. So this is a single frame here on the left. You can see a target. You can see my home point. You see me sitting in the chair like I usually do when I'm flying, because you get all cramped up trying to, hold the controller. That's the flight operations trail. It's from Walmart, So this is a blow up. This is still a JPEG of a PDF, but it still gives you an idea of the resolution. And I was flying at 153 feet above this point here. So from the bottom of the quarry, so from this point here, I'm 153 feet in the air. It's a better camera than the other one. It has a mechanical shutter. I can fly that drone 20 miles an hour at that elevation and get quality data. And it has 4 40-minute batteries, and they're hot swappable. So if that's even a thing these days. So needless to say, I can do 100 acres instead of 10 on one battery at the same quality. This is the new map edge right here, the old map edge underneath, and the old contours, but you can see a little bit more about what's going on. I think it looks a little crisper for these rocks. And trust me, I can sit in ArcGIS and look at which boulders have the thicker calcite on them, so I know which rocks to climb over to get to the fluorite, which is what the mineral that's popular here. I think it's in the old collecting guide too. So back to this for a second. This is our mission that's programmed in. Basically, all I do is go through some flight things in the controller, tell it to take off, and it takes off. It does all of its flight, and it comes back and lands itself. It's really, really dreamy. Almost forget how to fly it manually because you get so used to flying these missions. So in Pix4D, this is what a mission looks like. It's called mowing the lawn. It flies back and forth. The new drone will cut these round corners instead of coming to an abrupt stop and then making a turn, taking a picture, coming to an abrupt stop. And you watch the drone, the Mavic 2 would do this kind of stuff. And you're like, can't be taking a good picture. But it did, because it was only going about 4 miles an hour. So the yellow cameras up here failed to calibrate. And I don't know if, we talked about this is the high side of the site with the trees. Anybody want to take a guess why it won't calibrate? The twigs on the end of the trees, it can never find the same place to match. What drone software does with this, with the 70% side to side, 80% back to front overlap, is it does digital key point matching. In the old days, we take a couple of 9x9 stereo pairs and put them on a Kelch plotter, or put them on an Army surplus stereo plotter, find a couple of points, and then start tracing the geology. This software finds tens of thousands of points between each overlapping image and matches it. So it can't really do very well when it's trying, it's got all these little round twigs and they're really close to the camera and they're moving in the wind. So actually that's pretty good that it only did that. And we don't have any targets up there either, so there's no control. I could not fly with RTK there because there's no signal. There's no phone signal for it to get the corrections. So here's what the map looked like. The completed orthomosaic from 504 input cameras, 492 that were calibrated. So that's a lot. I've done them with 3,500 cameras. It takes a long time to process. So we're going to get into here really quick some of the structural stuff. This group of points is strike and dip data on the bedding surfaces near the top of the Jersey Shore, not the actual top, but near the top, very near the top. And this group is on the top of the Laval on that upper bench where I was sitting in my chair. So I just want to point out the conventional wisdom from the 2003 field conference of Pennsylvania geologists, stop 5. You can check this out for yourself. I just copied it out. The gently dipping limestone strike 190 degrees. That's south 10 degrees west. And dip 5 to 7 degrees west. Calcite veins 10 to 20 feet apart coincide with the dominant joint set oriented at 10 degrees and 85 to the east. These veins range from 1 to 10 centimeters in thickness, contain mainly coarsely crystalline calcite with minor amounts of fluorite. Secondary vein sets occur at 45 degrees to 55 degrees, 80 degrees dip, and 110 to not with 90 degrees dip. So we challenge that conventional wisdom. And I just want to point out here, if you can see this 7, 7, 7, 6, 7, there, all of those points, these are the geospatial locations for strike and dip data taken with the robotic total station. It requires 3 shots on the bedding surface to calculate the centroid and the strike and dip. And I'll show you the formulas for that in a little while. But these, you can see, north is straight up along the edge of the page here, up and down. So these are the dominant joint sets in the floor. They look like 10 degrees to me. Now that, you can barely see it because of the scale of the map, but that is the strike pretty much everywhere of bedding. These are my control points I had set down there. I painted them up as targets again for our new flight. So just using SoLocator, I'm like, well, did I calibrate, did those guys calibrate their compass declination wrong when they did their Brunton thing? I'm going to stand on it and I'm going to look down it. It looks like 11 degrees east of north, 11 degrees, I don't know, maybe 11, maybe 12. They were all 11 to 12 degrees north, literally straddling and looking right straight down it. So that's consistent with the literature. All right, so here's up on the upper bench. Now I want to point out these purple lines here. They are shots on the calcite veins. So that's the strike of the calcite veins. To me, that looks a lot steeper than 10 degrees. And on top of that, the bedding is almost all over the place. I tried to stay away from this edge. You can see how this is broken up from the shot. That data from that's not going to be any good. So we tried to get up here. And I've got 1, 2, 3, 4 big calcite veins. And I think this might be the big one that's buried that had some really nice fluorite in it at one time. And I have all these strike and dip data all the way around the room. Here's a picture of those calcite veins, just so you can see. These are some of the ones I shot right in this area here. Just comparing on the right-hand side. So this is kind of sort of coming around the curve back to where I was sitting. There's the helipad control points right there. This is where the robot was when it did all of its shooting. Again, 3 points are required to get a strike and dip, regardless of how you take it. They were these bedding shots because they were all taken with the rod. So has anybody seen this before? All this ugly math. Oneida University put this out, and I'll tell you who, Martin Helmke at Westchester University turned me on to this, and he sent the link to me like 3 years ago, and I lost it, and I had to go do a search and find it again. So at any rate, you need 1, 2, 3 points, and it doesn't matter that it's, state plane and not UTM. I mean, you put real coordinates in there, it calculates the coordinate value. You really can't put latitude and longitude in there. That's why they've got it set up for UT. They're using UTM up in New York State. So here's top of the blue here is all the Jersey Shore bedding shots. 1 through 9, 3 shots at each location. I can't quite read it from here, but we'll get into it in a minute. These are the beds that I shot, 11 through 30. I think a couple got skipped in here because they just were bad. I didn't have a 29. And so this is all the top of the Laval, all the way around that fishhook shaped rim. And then these are joint sets, but I'll tell you that these joints were all shot from that position near the helipad, looking in whatever direction it could look in. In order to get the shots on the calcite veins, I would have had to been at the other end of the quarry. And the problem with that is all those ledge blocks are kicked out. They're disturbed. So one, this is an adventure and proof of concept, not an actual job. And two, if I shot all that data, I couldn't really rely on it. So here's the math. I don't try to get into this. I mean, all I know is that it works and I can reproduce the data. So here's the strike and dip calculator for the first group of beds. And everything over here on this right-hand side, down here, this is all input that I added so that it would put the data in an order that I could drag back into CAD or ArcGIS and plot. It doesn't do me any good to have all of this stuff all over the place. Point number, northing, easting, elevation, description, strike and dip. And you can see that I have, 3 shots for every single one. All right, so here's the plot. Here are the control points. You can see 1, 2, 3 points in a centroid. The elevation is 1365.09. The position is the position you see. And the bed top 2 has a strike of azimuth of 216. That's certainly not 10 degrees south to west. That's what, 36? Yeah, south 36 west. They're all high compared to the literature, all of them statistically. And you can see that they're consistent. So the GeoRose, the free GeoRose by Young is, here's your strike, here's your dip, and then, well, actually strike and dip direction, sorry, and the dip, because the beds are almost flat, you can hardly even see it. So same thing for the top of the Laval. Here's the strike and dip calculator. This is the output from that. 224, 217, 228. These are all azimuths. And the way this thing works is, we know that we can say northeast and southwest, but the azimuth tells you it's always 90 degrees right as far as the math works. So that's why it's giving you an azimuth that's, not in the northeast quadrant. So look at the dips. As you work your way around from the top of the Laval at the far end, sort of the middle upper part of the quarry, around the fish hook, and you can see that the dips flatten out and then start to steepen again. So here's a map of that. As you work your way around, those dips, so you're actually seeing something happening here in the quarry with a slight change in, and if they blasted all of this out, we would still have this data. If they took out another bench, which they're not going to do because the quarry's done, but if this were an active quarry, you could take this kind of information on every single bench. So here we go with the strikes and dip direction. Top of the Laval, average of 18 measurements is north 32 degrees east, dipping an average of 3.2 degrees northwesterly. That challenges the literature and the conventional wisdom. And the reason is because, we've got much stronger data the way the data is collected, that's a very, if you've ever tried to use your Brunton compass on a bumpy surface and it's nearly level, you're never going to quite get it right. But I suspect that there's a typo in there, knowing who actually did the field stop. So anyway, the geologic map also indicates the fold axis strikes approximately north 26 east. That's scaling it off of the old geologic maps. So that, you know, our data is a little bit more consistent than North 10 with the actual axis of the fold. So rotation of loose blocks due to blasting is a factor close to the edge of the bench. I tried to stay away from that. So here we go again. These shots, I don't have any data on. I didn't trust the strike and dip data because I'm shooting obliquely at the underside of the surface above the bentonite beds. But I do have the elevations at the top of the bentonite beds pretty accurately. So you can still get data, and that data was gathered reflectorless, not with a rod. I simply pointed and shot 1, 2, 3 on a surface, and we get the information that we need. Don't ask me why I need it, but we got the information. So here's all the joint data for mostly subsidiary joints, not the primary joints. And you can see the data is all over the place. We got a really crazy looking spray going on here. If we were at the other end of the quarry and it shot all those north 20 something joints, we would have a really strong presence here. But these are all of the secondary joints. These are the dip directions, and these are the dips. So all the dips are nearly vertical, as opposed to bedding, which is pretty flat. So just some suggestions I thought for future work. I shared this with Steve. We could recover these borehole locations because this map could be stretched and georeferenced. And we know it's on the quarry road about this position. If we could find the drill hole, which I think, you know, a couple of people poking around, we could probably find the drill hole. Then they have the log for that drill hole. And Steve's working on getting the actual cores from the quarry. So that could be interesting for this as a study location for UPJ students. If anybody ever clears some vegetation, we could put some more control in, do a little bit better flight. Accurate measured sections, I think that's going to languish until they remove all that material from the quarry. And Steve says it's their contract is that they can't take that material out and sell it for 7 years. So I think they're 3 or 4 years into that now. So any questions? Whoops, that was a long one, wasn't it? You guys wore out. Thanks.
All right, so those of you online, if you want to put your questions in the chat. Is the wavelength fluorescent?
Some of it is, yeah. The dark, there's something on the dark green ones on the outer surface of fluorescence bright lime green.
Because they want to try maybe collecting.
No, I don't think Eric would allow us. Active quarry, probably.
Oh,
I'm pretty sure he wouldn't allow it.
Hey,
Yeah.
it's a collective.
Did you?
Yeah, you get, I think you get a Bible ceremony because there's your price of admission.
Yes, that's the price of admission. Eric will give you its testimony as a Gideon. Sometimes it's just, I love rock hounds. Your rock hounds are great. Sometimes it's the coming apocalypse.
Well, that's
Just, you know, just don't step outside, because if you step outside, you're
this guy. I like him.
He's a good guy. His brother's a good guy. And little Eric ran the machine for us. That was 200. So I'm glad we got something out of it, but amazing for Pennsylvania. I would say that this is equal to Arkansas in terms of its Simon and Schuster rock and mineral color photo. Definitely. Yes, sir.
It's such a dug out there. Are they still open, or did he have to fill those back?
No, they're open. We decided that we weren't going to backfill them because the whole thing got dead after a while. And I think somebody went in there and they dug down, 8 or 10 feet and put 4 or 5 feet of cover back over the beds, and nobody could find anything. So when we dug it out, We dug all the way down until we hit basically sand, ran out of it, and then took all the overburden, built the road up so you can go up to the top, turn around, and covered up the backside where, you know, where we've been digging before. So there's still, you'll be digging underneath the tree roots, but you can still get to it. And people were in there not that long ago, finding some pretty nice stuff.
We've got some questions online. So what is your drone data management strategy?
Management strategy?
Like you're collecting all this data, like how are you managing it? Where are you housing it?
I have 29 terabytes on my 48 terabyte server. And my plan is on the older NAS drive to swap out the 4 terabyte drives for 8 terabyte drives. So I can boost it up to 60 terabytes. After that, I'll probably be retired or, but frankly, we have a tremendous amount of imagery. I've 4 generations of half-pixel resolution for the entire state of Maryland. Entire state. Just all of my business projects are just a couple of terabytes, and then the rest of it is imagery. It's a man eater. Each one of the Mavic 3 Enterprise cameras is typically about 15 megabytes. So if you start taking 300, 500, 2,000 cameras per job. So we have an organization of projects, and we keep that information with the projects, and then it's automatically backed up to the second mirrored server, and then at the end of the year we push it off. But it's challenging. And I'll also say, if you give up on the software, you can't go in and do anything with it. You have to churn out the products. You have to churn out the orthomosaic. You have to churn out the DEM. You have to churn out the contours, and you save those. You can always open that up in ARC, but you can't go back in and pick information out if you quit the software that you're using. So it's a commitment.
We got another question. What exactly is a skeletal quartz crystal?
A skeletal quartz crystal is a quartz that doesn't have flat faces. The edges grow preferentially, and it's thought that they grow more rapidly than the interior of the faces, and it leaves furrows, often cuneiform in shape. And it's just a crystal growth habit. And the other part of that is fenster. Fenster means that the skeletal crystal will grow around the edges, and then at some point in time, it grows over an open gap. It may or may not close it off. And looking through into that gap, that's your fenster or window. Fenster is German for window. And the other part of it is you can trap mud or fluid in these pockets within the crystal. I don't know if that's helpful or not, but grows faster on the edges.
And you mentioned there's petroleum in those, some of those?
Well, the anthraxolite was petroleum at some point in time.
Okay.
And I'm not a petroleum geologist, but the way a lot of the information is coming in about the saddle dolomite vuggy reservoirs in the Black River and Trenton groups that are younger, and the way they seem to show these fracture systems and negative flower structure fracture systems coming up out of the Little Falls Dolostone, the Cambrian, anything in the Beekman town. To me, it just seems like the stromatolites in the Little Falls dolomite were organic. So
Yeah.
to me, it seems like that would be, it's just the thermal maturity is such as practically turned it into coal. But higher up, it's oil and gas.
Okay, got one question. Have you photographed vertical surfaces, like outcrops or high walls to make 3D models? So have you had success using ground control points in the creation of these models? What is your method for collecting photos from these features? It keeps going. I find these types of features challenging to photograph in models, especially vertical to near vertical features that offer very little to see from top down photos. that one would collect in a traditional map. It's challenging to get ground control points in view and a variety of elevations, nonlinear distribution throughout the modeled area.
Okay. All right, so the way we're doing things now, the Mavic 3 Enterprise is capable of running a mapping mission. It's called Smart Oblique. It will take the traditional nadir photos right up to your flight boundary. And then it does this crazy thing. It goes way, 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 way out and starts taking 45s all across the site. Then it takes a nadir and then it turns and takes 45s going the other way. So it literally, don't ask me how, because when we went to school back in the day, they said if you're more than 3 or 4 degrees off a nadir, you can't do it. Well, I can't imagine what the math is like, but they figured out a way to do it. So now the way we will be doing that is we'll be doing Smart Oblique and processing it in Pix4D. There's a selection tool you can predict. You can do nadir or oblique in Pix4D, but you've got to plan the flight. So before that, when we just had the Mavic 2, and I did this at the new Enterprise Quarry on one of the field conferences. I think it was the new Enterprise Quarry, one of the quarries we went in on the field conference. I literally just, I got to a certain position, I got in horizontal, and I just dropped the drone in elevation manually, taking overlapping photos. Now I can piece that together in an inexpensive, photo panorama type thing, but I can't scale it. So I had this bright idea. I get a high-powered paintball gun and shoot the targets, and then shoot them reflectorless with the robot. I never got to try that. So you could literally just turn it on its side, treat it like it's nadir, because you're horizontal. You're just, it doesn't know what you're putting in it. But we never really completed that. And now it seems silly, but there's no easy way to do it. There really isn't an easy way to do it. So I hope that answers the question. Buy a new drone.
Yeah, the response, that's exciting to hear. I'm struggling to find an automated method to collect those critical features with the Mavic 2.
You can't do it. I tried. There's no hack. It's no hack.
So new drones and.
Yeah. Or you can just hire us and we'll do it.
Any questions?
No. This, I've never worked with drones or the Mavics or anything like that. But several times you mentioned these slides that you're putting up there were JPEGs taken from PDFs. Is PDF a native format?
No, see, I import the cameras into Pix4D, into the software to process them.
Right.
They overlap 80% front to back, 70 side to side. And I import them, they calibrate. Then I do the ground control point tweaking. A lot of times it can find, the targets on the ground, but you have to match the GCPs. Once it does that, it goes through the process of creating a seamless orthomosaic. You don't see camera edges, it just makes the image. So the orthomosaic is 2D. We bring that into ARC. And then what you're looking at is either exported directly as a JPEG or as a PDF that I decided I'd convert part of it to a JPEG so I could put it in the talk. So it's automatically degraded from what you would see in ARC. But it's a post-product extract just for our talk. If we could sit here and look at ARC live, you would see just how, I can accurately measure flying that drone at 120 feet and orthomosaic with ground control. I can actually accurately measure the width of an expansion joint in the concrete curb. And I could show you where we've surveyed curb pavement edges, and it's smack on top of the photo. It's unbelievably accurate if your ground control is good. Does that help? The original ortho,
Format. The Mavic itself.
actually, they are, oh, I don't really know how they're coming in. I hadn't looked. They may be JPEGs coming in, but each one of them is 15 megabytes, so they're huge.
Size, but
Well,
They have to be matched, right?
well, they're key point matching digitally. So you're talking about 10, 20, 30, 40,000 points, matching and there's some minimum. You can cut it off and you get a quality report. So when you're looking at stuff out on the edge, it's really poor quality. When you're looking in the middle where you have lots of them overlapping and you're inside your control, it's pretty accurate. And just to give you an idea, the ground sampling distance for 153 feet of altitude above your point is a little over a centimeter from center of pixel to center of pixel. So how many square centimeters can you put in a 1 foot pixel block? If it were even an inch, it would be 144, right? 12 by 12. So you're looking at 24. I can't do the math in my head. 24 by 24, 2.54 times 12, both ways. That's a lot of density of pixel imagery. So you can really zoom in close.
the amount of data is mind-boggling.
All it is, if we didn't have modern equipment, you see, we couldn't do it without the tools and the software and the hardware. You couldn't do it.
That gets me to my question.
Yes.
I didn't see that you have a license as a professional surveyor, but nonetheless, you're doing surveying. Of course, you're not property surveying or something where you need
No, I
license,
mean,
but
there are three things that are going on.
it seems that you've done this because this is your interest.
Well,
You're driven to take these pictures, make these maps.
there's really no one controlling mapping, as long as
Right.
you can call it mapping.
Call it mapping.
Now, I'm a special case
Yes.
because I have a licensed surveyor on my board of directors and a licensed professional engineer is my supervising engineer. Some of you may remember Mike Rocky. He's my engineer.
Okay.
And so Pennsylvania, Jersey, Maryland, Delaware. I have a licensed professional surveyor that's licensed in those states. And Pennsylvania, Maryland, Delaware, Virginia, somewhere else. Mike's registered. In Georgia and Utah, where I've been doing some erosion sediment control and SWIP planning on some military bases, I can do the work as a licensed PG. And so, I mean, and nobody's questioning the mapping or the tools I'm using. My point of view is this is geologic work.
Right.
And just because it's accurate and just because I'm using survey tools doesn't mean that it's surveying as defined in the regulation. Trust me, been in business 28 and a half years. I know exactly where to walk. So, but your point's well taken. And I,
Accumulate.
we have the Part 107 FAA certification. I've had it for years. And we maintain that. So you can't do commercial work with drones and sell it.
Yeah.
Unless you have that. There are people out there that are selling pictures and all kinds of things. So the thing of it is that who's catching them, but the drones record your flight. So if you crash a mofo and hit somebody and it has to be reported, well, it's all in the box, brother. You're not getting away with nothing. So we have to, and we report that annually. I don't think everybody's doing that, but I mean, the nice thing about the newer drones is it records all the things you used to have to do manually. And the flying over people thing, that's kind of relaxed, the flying over traffic. I mean, we just, we're not hanging out at, a stadium when there's 50,000 people watching Shania Twain or some kind of concert or something, just hanging out doing video. We're mapping. So the chance that the drone's gonna fall out of that, and that's why I like the little drones, because they're not gonna do much damage. I mean, some of these drones, you know, like the Mavic, 610 or 300, you know, towing a rock robotics LiDAR payload, you know, it's 30 some pounds, that falls out of the sky, hits you, you're gonna hurt. It's going through your windshield, you know, so these lighter drones that are only a few pounds, and they're much safer. We haven't had a flyaway yet in 5 years. That used to be a big problem. So, I don't know if that's helpful clarification, but if somebody says, where's your surveyor license? I'm like, hey, hang on a minute. Hey, Mike, hey, you know, it's
A lot.
yeah.
So we have insurance cover problems.
Yeah, actually, we have to have $1 million in insurance on the drone for accident, plus we have insurance on the drone to replace it. Plus the 2 million per occurrence, 3 million aggregate, you know, CGL, you know, all that other stuff you have to be in, you know, professional practice. That's why, you know, I learned early on that, you know, when you're an employee and you see somebody billing and you're out at like 75 an hour and you're making 20, you know, wow, he's making all the money. No, he's not. He's got to pay this bill and that and the other, and then somebody doesn't pay him, and, you know, before you know it, it's, you know, not making what you think you're making.
Well, thanks a lot, Bill. This is.
You're welcome. Yep.
So, that's our December meeting. We do not have a meeting or scheduled for January. Yeah, we need a breather after the holidays, and then we'll come back on in February. And we're still looking for volunteers to head up some social committees. So as you notice, we're no longer wasting dinner. We'd like to resurrect that, but so anyone who'd like to volunteer for that, or we're also looking for give us some people to something. So see me, send me an email. Let's get some ideas.
I think I forgot to mention, the Friends of Mineralogy National Annual Symposium at the Tucson General Mineral Show, February 10th, Saturday, February 10th. We'll have 9 speakers, experts on pegmatites, and I will be live streaming it. It's free. That's for 6 credits if you need. If you're a PG and you need credits, and if you're interested in pegmatites, everything from guys that are doing growing them in the lab. It doesn't take as long to grow a crystal as you might think in the right place. Or if you're interested in, you know, heliodorus and the Urals or something like that,